Welcome everyone. Today I'm going to discuss about the computer simulations, and I want to give thanks to the University of Calgary performance evaluations part I will discuss. Performance evaluation, performance measurement, including performance modeling, analytical modeling, and simulations. Simulations model, taxonomy, system model, deterministics, scholastics, stat, dynamic, continuous descriptives, static, motor, cardio simulation, dynamic, continuous, and discrete, decrease, event simulations. Terminology. A system is defined as a group of objects that interact with each other to accomplish some purpose. A computer system, CPU, memory, disks, bus, NIS, and automobile factory, machine, component parts, and work operate jointly along assembly line. A system is often affected by the change occurrence outside the system. Systematic environment, her salon, arrival of customer, warehouse, arrival of shipments, fulfillment of order, effect of supply on demand, relationship between factory output from suppliers and consumer by customer. Entity, an object of interest in the system, machine, in factory. Attributes, the property of an entity, speed, capacity, failure rate. State, a collective of a variable that describe the system in any time, status of machine, event, an instantaneous occurrence that might change the state of the system. Breakdown, developing a simulation program that implement a computational model of the systems of interest, run the simulations program, and use the data collections to establish the performance measurement of interest. A system can be studied at an attributes level of details. Quote of the day: the hardest part of about simulation is deciding what not to model. Advantage of simulation: new policies and procedure can be explored within the disruptions or the online operations of the real system. New design can be tested without committing resources for their acquisitions. Time can be compressed or expanded to allow for a speed up or slow down to the phenomena under study. Insight can be obtained about the interactions of the variables and which ones have the most impact on system performance. Can obtain answer to what if question. Model building a require specific training, an important role for the course like CPST 531. Vendor of simulation software have been actively developing packages that contain models that only need input, which simplify this for users. Simulation result can be difficult to interpret, need proper statistical interpretation for outcome analysis. Simulations modeling and analysis can be time consuming and expensive both for the modeling as well as in computer time. When the problem can be solved by the common sense, when the problem can be solved analytical, when it is easier to perform direct experiment, when cost of simulation exceeds saving for the real system, when system behavior is too complex. For random number generator based use well-known or the well-understood generator, improper selections of the seed for printing, short period same seed for all streams, inappropriate level of details, more times, more bugs, more parameters, more accurate, improperly handle initial condition, improperly handle ending conditions, run length too short to achieve steady state, need proper outcome analytics, confidence intervals. Type of simulation: Monte Carlo situation, time step simulations, trade driven simulation, decreased event simulation, continuous simulations. System model: deterministics and stochastics. Monte Carlo simulation, estimating curve, time step simulation, mortgage scenario, trade driven simulation, single service query, discrete event simulation, discrete hair salon. Statistics simulations to model probabilistic phenomena can be used for evaluation. Non-probabilistic expression using probabilistic method can be used for estimate questionnaire that are hard to determine analytical or experimentally. Trace is equal to time-oriented record of event in system. Trace-driven simulation tracking often used in evaluating or turning resources management algorithm, packing, cache analysis, CPU scheduling, deadlock prevention, dynamic storage allocation. Example: trace start time per durations of the people. Trace is equal to size in bytes of files written to disk. Trace is equal to model devices ID and call duration. Credibility is easy validation compares simulations with measurement, accurate workload model correction and interference, fair comparison better than random input summary. Similarly, to be actual implementation, track-driven model is similar to the system can understand complexity of implementations. Complex, more criteria representative workload changes with the time. Data collection, few minutes fill up a disk. Instrumental granularities and instructive single point of validation, one track of one points and difficulties to change worldwide. Simulations model with the three stochastics, dynamic, and discrete event. A discrete system is one which the system changes only at the discrete set of point at a time. A restaurant. A continuous system is one in which systems start the changing continuously over time. A simulation model is which system state evaluate over a discrete sequence of event in time. System that state change only when an event occur. System state does not change between the event. A simulation model in which system state evolve continuously over time. Time is divided to the small time silence slices. System state change in every time silence. Determine of stochastic. Does the model contain stochastic components? Started with dynamic is time is a significant variable, continuous or discrete. Does the system is evaluate continuously or only discrete point in time? System model. How to develop a simulation? Determine the goal and objective. Build a conceptual model. Convert into a specifications model. Convert into a computational model. Verify the model and validate the model. Conceptual model, very high level. How comprehensive should the model be? What are the state variable? Which one are dynamic? Specification. One paper may involve a question: how will the model receive out? Uh, a computational model, a computer's program, a general purpose programming language or simulation language. General purpose programming language, flexible and family, well situated for the learning DS principle and its techniques, e.g. C plus and Java. Simulation programming language, good for building model quickly, provide built-in features, graphic and animations provider, domain and specification, network prototype simulations, electronic power simulation, design and engineering analysis, process simulation. Verification. Computational model should be consist with the specific model. Did we build the model right? Validation. Conceptual model should be the consistent with the system behind analyze. Did we build the right model? Can an expert distinguish simulation outcome from the system outcome? This is the very basic interesting things, and if you have any question regarding this point, you directly can communicate with me. Thank you. Bye bye and take care.